Welcome to the Kubernetes New York City meetup and the DigitalOcean New York City meetup. Can I see a quick show of hands of like who is here for the Kubernetes meetup? Yeah, and DigitalOcean. All right, cool. Good to see a blend. We've been working together now for a few months, and it's exciting. We're going to start doing DigitalOcean specific meetups in the next couple of months. So I'm going to help organize that. My name's Ariel, by the way. I'm one of the founders of a company called StackPointCloud, and we work with DigitalOcean on various fronts. But I'll be helping organize that event also, and I'm looking for a co-organizer. So if you're interested, go ahead and hit me up just on meetup. You'll see, just hit message me, and or you can hit me up on Twitter. First name Ariel, last name Jatib, J-A-T-I-B. I'll post it up in a few minutes. So moving on. Today we have 3 presenters for you. I'm going to flip it up a little bit because Iheanyi and I, Iheanyi? Got it? I'm working on it. Are going to be presenting a little bit on DigitalOcean firewalls, and then I'll be presenting a little bit on the context within a Kubernetes context, like what we do with it, as we at StackPoint did an integration with it. After that, we'll have Karthik from Tigera Calico presenting. He'll be presenting on Istio, Envoy, so that's exciting. Brief background on Karthik. After years of experience with large cloud infrastructure deployments involving Kubernetes or OpenStack, Karthik discovered the power of Calico, combining a scalable, simple IP-routed network fabric with distributed intent-based policy enforcement designed for cloud-native scale. He is now focused on building awareness on how to build and operate network and policy infrastructure at scale for cloud-native workloads. All right. And then we'll have Flynn from DataWire. We had DataWire a couple months back. We had them come back. They're going to be speaking on Ambassador, which sits on top of Envoy. Did I get that right? Awesome. And he is the principal software engineer at DataWire. His career in computing spans more than 30 years. He looks so young. And runs the gamut of bringing up bare metal up through mobile applications with a common thread of communications and security throughout. Recently, he's been working on tools to help developers take advantage of microservice patterns to be more effective. The microservice aspect of it is a focus of the folks in DataWire, and we're grateful that they ventured down from Boston to present to us. First up, like I said, Iheanyi and I are going to be talking. He's going to be going first. Iheanyi is a software engineer here at DigitalOcean on their high availability team. He focuses on building out delightful and scalable products throughout the entire stack. In his free time, you can catch him playing Overwatch or recording an episode of the podcast he hosts, Two Black Nerds. Before we get started, I'm going to show you a little something. Let me see if, all right. Does that work? So this is actually, I'm going to spin up a cluster. I'm going to show you how we do firewalls. Later on in the talk, I'll take the firewalls product and I'll explain how in a Kubernetes cluster, best practices that you should be applying as far as it relates to firewall policies. So I'm going to go ahead and add a cluster. We'll do it on DO. And we'll take Helm out. One of the things I'm going to do also is I'm going to add Prometheus, something we rolled out last week for CoreOS Fest is a bunch of pre-installed dashboards. So you get a bunch of visibility into your cluster right off the bat. And that's it. Hit that. That's going to get building. It'll take about 10 minutes. And in that time, Iheanyi will take us a little bit into the firewalls product. So I'm going to hand it off to him.
So yeah, As you know, we released our product Firewalls on Tuesday. How many of y'all are active DigitalOcean users? Just a show of hands. Nice, I like to see. How many of y'all have used our Firewalls product? All right, way less hands, gotta change that. But yeah, so I'm gonna show how to really get started with the firewalls. If you go to the networking tab and you click on firewalls, here we have no firewalls created. And a lot of people have been asking, why should we use DigitalOcean firewalls over something like IP tables? Well, for one, IP tables are working at the droplet level, so it uses the resources up on your server to filter out the packets and just handle all of the specific security policies. But with our firewalls, we're actually handling this at the hypervisor level. So we're filtering out the packets and making sure that none of them can, depending on the policy that you have on the firewall, we say, oh, okay, you have TCP open on port 22. Okay, an SSH connection, let that through. And that's handled at the networking level. So that way we're not using up any of the resources on your server. So I actually have a couple of droplets created here. One at this IP address. Let's see here. Oh, crap. There we go. Let's see, we're going to create two things. I'm going to create a demo firewall, allow all TCP on all IPv6 and all IPv4. And I'm going to apply it to droplets, demo droplet 1 and demo droplet 2. And what this is saying with each rule is it's basically designating what port and protocols we want to open up. So it can be UDP, TCP, and ICMP. And then you can also do singular ports or port ranges. So for the sake of this demo, I'm just going to do TCP for now, create firewall, and I'm actually going to find the ID of this droplet. And so now if you see, I'm going to do an SSH. Oh, crap. Oh. Let's see. Don't need this. I'm in my droplet, but now what you're going to notice is if I exit out of this and then I do a ping on that, it's timing out. Now, as we keep this connection open, I'm going to go back to my firewall here, and I'm going to add in a new rule that allows ICMP from all IPv4, or actually I have a better idea. Let's do curl, I can has ip.com, pb copy. Yep, I'm gonna see if I can do this live. Let's add my local IP address and see what happens here. And save, see if we can get fancy with it. And now you're seeing that before I was rejecting it, and now it's persisting that connection and letting the packets through. I think there's a lot of powerful ways of using these droplets. You can't, firewalls. You don't only have to apply them to droplets. If you go into this droplets, you can add actually tags, and you can apply them to various tagged droplets. So let's say you're running, just a various droplets, and you have some of them tagged with like production or some of them with database. It's nice to like organize it. So if you're having database specific droplets, you'll have a permissive policy for running it on, what is it for MySQL, 3306, opening up that port via TCP, or even just for like production web-facing services, opening it up on port 80 and 443 for HTTP and HTTPS respectively. And I think another thing that it plays nicely with is in the rules, if you, let's say you have, let's just do HTTP. You don't only have to deal with IP addresses. I can actually type in demo droplet 1, demo droplet 2. And so if you have droplet to droplet communication between your various services hosted on your droplets, you can add permissive policies for that. And also, I'm going to go ahead and just add demo load, what did I name this? LB? Yeah, load balancer here. I'm going to save this, delete all TCP on port 80. So I added a load balancer and a peer role here. I actually have this load balancer created over here. And essentially, we just released our load balancer product back in February, I believe. And the benefit of doing this is that what we get is, let's say I want to access these droplets. Oh, wait a minute. Did I not close it down? Oh, I remember why. I'm going to delete rule, all TCP. Yeah. So the benefit of doing so is if you wanted to lock down your droplets, so you don't get, so you can only have a load balancer speaking to the droplet. That way, users won't be able to access your droplets' IP addresses directly, but the load balancer will still be able to interface with each of your droplets and balance the traffic between the two nodes or servers. And yeah, you can also use tags and rules. So if I have like a tag called demo, I can apply that. All services, all droplets that have that tag will be able to communicate with with the droplets applied with those rules. So it also is good for like inter-process communicate or inter-droplet communication as well. And another benefit of this API that we have is we have full support for our API. And let's see, firewall list. Yeah. So you can also use doctl, which is our command line tool for creating these droplets. We also have a Go package called Godo or GoDo. Oh, yeah, what's up? Sorry about that. Yep.
Are you able to filter specific types of ICMP, or is it just all or nothing?
I think it's all or nothing for now. Yeah. Yep.
Which encryption standard are you using? You're using AES-256 for your encryption, or you have another encryption standard to do your firewall from where you have to encrypt the information?
I'd have to get back to you on that one. Any more questions? Okay. But going on, what doctl and Godo do is that they're like wrappers or libraries around our public API. And yeah, so it's nice for using the public API. You can we have a PR open right now in Terraform with HashiCorp. So if you're provisioning droplets using Terraform, you can just specify your roles, your firewall policies in that, and have the droplet automatically create with those firewall policies as well. And I think actually StackPoint uses the public API for doing the provisioning of a Kubernetes cluster. So I'm gonna give it over to Ariel to actually talk more about how they're doing that.
Hello? There we go. So I'll talk you a little bit through best practices for firewall policies in a Kubernetes cluster. As Iheanyi mentioned, we leverage the API in order to accomplish all this. And so I'll start with the basic. I'll use the droplet metaphor here, but it's nodes, right? And so a 3-node cluster, master 2 workers. We'll set up the firewall, and then we open up ports for SSH, HTTP, HTTPS, kubectl or kubecontrol, right? That's debate. 6443, that's not a standard, that's best practices, right? That's the pattern that we're seeing out there. And then standard node ports, 30,000 through 32,767. And if you're using something like SockShop, I think it's set to 30,000 by default out of the box. Additionally, then within the cluster, we go ahead and we open up port 10250, and that's used for kubelet, communication, masters and workers, and we do that to limit the power and the control that we send to the pods, right? So it's a security feature. And then for the network overlay, like Flannel, VXLAN, we open up UDP port, everything 8472, and that's due to the amount of the volume of traffic that occurs over this. Why do we secure it in this way? Because it's really easy to understand for beginners. So you can always, it's a great starting point, and then you can always come in and kind of set your own policies. Let me quickly switch over to the cluster that I hope should be built. Yeah, all right. Here we go. How long did it take? 7:13, 7:24, yeah, so about 10 minutes. I'll show you. So there it is, it's all set up. There's the firewall. Let me actually show you the nodes. So there's my node, and here's the policies all set up. Why do we do it this way? One of the philosophies we have at the company is convention over configuration. So the idea is we are going to apply best practices to whatever it is that you're doing, and rather than forcing you to configure it yourself. And so here it is, again, via the API and leveraging labels, tags, all the rules set up. And that is, let me see, what else was I going to show? Oh, let me show you the Grafana. And so here's my cluster. That was not set up. It takes a little while sometimes for that. I also have a multi-master. So one of the things we actually, that's in staging, you're looking at our staging environment, but that we look to also deploy to production here in the next week. And again, using the API, we added load balancers. And so what we have here is a multi-master environment, which is something we've added recently, or the ability to add node pools or multi-masters. And it varies a little bit from provider to provider. But here, let me show you. This has been running for a little bit. This is what the dashboard looks like. On the box. I have all my nodes and all my stuff set up. Go look at pods. I have. It's actually really easy to deploy Istio, like from here. I just got to go in kubectl create file. I think it's Istio YAML, the file. That's it. All right. Let me give it one more shot on the other cluster. Load it up. There it goes. Yeah. See. So there it is. Should start. All right. Cool. Let me go here. So last thing, if you want to try all this stuff out, went back. Here's a code. It's gonna happen. All right, let's go back. DO Kubernetes 15. You got $15 at DigitalOcean, and with that, in 10 minutes, you can play around with firewalls, Kubernetes, Istio, all the goodies. Thank you very much. Questions? Awesome. All right, we'll move on. Karthik from Tigera Calico.
So thank you all for coming, and thanks to our hosts, Ariel and DigitalOcean as well, for hosting us. So I know you want to get to the Istio and Envoy part, but before I get there, I have to do the obligatory. We are hiring, and I'm going to do this up front, because if you have any sort of deep skills in networking and or Kubernetes, we'd love to talk to you. Have my cards in the back. If you want to come work on some of the exciting things going on in Kubernetes networking, come talk to us, okay? So let me start there. Before I sort of dive deeper into sort of a service mesh, I want to just do a quick poll, because I'm assuming you guys are at a Kubernetes meetup or at the DigitalOcean meetup. So you have some familiarity with Kubernetes, I'm going to assume. I'm assuming you've all at some point deployed Kubernetes. I've spoke to a few of you who hadn't yet. But when you look at Kubernetes networking specifically, These are sort of common concepts, and I still talk to people who are confused about some of these concepts. How many of you understand what these are in a fairly good depth? Okay, so roughly 1/5 of the room. Okay, so I want to just do a couple of minutes to do a quick intro to set some context for you guys before we dive into the deeper concept, right? So from a Kubernetes networking perspective, obviously in Kubernetes, your application microservices are being deployed as pods. A pod is a collection of containers with a shared network namespace. And so typically from a networking perspective, there's sort of multiple abstractions that come into play in Kubernetes. All of them typically work in concert with each other. And assuming you use implementations of those concepts that work in that abstraction, things generally work pretty well and work at scale. And to kind of go through what those are, so the concept of CNI, or Container Network Interface, is an abstraction by which different network plugins can interface into Kubernetes. Kubernetes chose CNI, and they provide pod-to-pod connectivity. So when you have an application that launches dozens of pods or hundreds of pods, those pods typically get an IP address, and they communicate over IP. And the network plugin provides that communication. So different plugins have different approaches to do that. I'll quickly mention Calico as one approach, which is a very scalable and simple approach that a lot of people use in the Kubernetes community. But there's numerous other approaches. Tigera, the company I work for, is the company behind Calico, but we also co-maintain Flannel. Tigera, some of our people are actually co-maintainers of CNI, the CNI interface itself. And we're pretty active within the Kubernetes networking community in maintaining some of these concepts there. Alongside CNI network plugins, you have the concept of network policy. And this is something we'll come back to when we do the demo on Istio and Envoy, which is, so network policy is the concept by which an application developer or a deployer can express in a declarative fashion, typically through YAML syntax, how you want your application flows to be isolated from each other. So this provides you a much more declarative way to provide security enforcement rather than the early days of VM networking, where the ways that people provided isolation between flows was to create multiple network overlays. And what that caused was, back in the early days, that caused you to have this sort of very complex network overlay mechanisms, and it caused performance issues, it caused operations issues. It was really, really hard to scale to large infrastructure sizes. So what Kubernetes has done, and in fact all of the container orchestrators are moving this way, is to now provide an ability to declaratively describe how your application flows need to be isolated from each other, so that you can really isolate them in a much more scalable approach, and at the same time try and simplify and make the network more scalable, right? So we'll come back to that as well. The concept of services is a way where you're providing an abstraction so that you can reach individual microservices independent of how many pods are actually implementing that in the back end. And so the concept of services in Kubernetes is typically expressed through kubeproxy or implemented through kubeproxy, which gives a service a cluster virtual IP. You can give it things like a node port if you want it externally accessible. And you can also plug into things like external load balancers, such as your favorite cloud load balancer if you want to. Another concept somewhat distinct from that is the concept of Ingress, where you can use things like application level headers or HTTP headers to process traffic and redirect traffic in a flexible fashion coming into and out of the Kubernetes cluster, right? And the concept of service mesh, which is one of the newer concepts, is something that allows you to do a lot more flexible traffic management, load balancing, application-specific capabilities that we'll talk about in more detail today. And service meshes, like in the case of Istio, for example, it can actually plug in as an Ingress controller, but there's other elements to it in terms of both east-west traffic as well, and we'll talk about that in more detail today, right? So these are all concepts that are part of sort of the Kubernetes networking fabric, and in a nicely designed system, they should generally work with each other, so they all sort of work in concert with each other. I will reemphasize this. One of the nice things about Kubernetes is that it decouples network policy from the actual networking mechanism. So now it allows you to declaratively express what you want in terms of isolation between applications. And that allows you to focus on the networking part of Kubernetes on just connecting workloads together, right? So that is a fundamental concept that Kubernetes brings to the table. And an example of that, just a quick plug for Calico, is that Calico is an example of how you can do this in a very scalable fashion. It's an open source project. It's one of the more commonly deployed plugins with Kubernetes. It is one of the reference implementations, if you will, for network policy in Kubernetes, given that the team behind Project Calico helped develop that specification for Kubernetes, which is now moving into full it was beta until 1.6. Now in 1.7, it's being escalated, being brought out into full support on Kubernetes. And the way this works is in Kubernetes, when you have Calico working as a policy plugin. By the way, Calico works across multiple orchestrators, not just Kubernetes. It works on Mesos, it works on Docker, it works on even VM-based platforms like OpenStack and others. It also works from a policy perspective on Linux instances. So if you have Linux instances in your favorite cloud, you could tie it into this dynamic policy environment seamlessly with Kubernetes. So if you have a database running on a host Linux instance and you need to tie it to a Kubernetes environment and be able to manage policy dynamically, Calico can do that. But the way it works is that there's the policy enforcement part of that, and that is captured through a declarative fashion where when someone deploys an application in Kubernetes, in the pod spec, you will be declaring, okay, this is a Redis application. And all of the pods that you spin up are going to be labeled Redis. They're going to be labeled production, and they're labeled belonging to project A. And in that, in the network policy, you will express in YAML format that all Redis pods need to be allowed to talk to all, for an example, Nginx pods over port 8080. And as Kubernetes spins these pods up and down, that policy is dynamically enforced by Calico as the network policy implementation, irrespective of where in the infrastructure and how many pods are running in the infrastructure, right? So that policy is implemented by Calico using IP sets in the Linux kernel. And what that means is if you have 50 Redis pods and 500 Nginx pods, that you can actually look up in a single IP sets lookup what needs to be allowed to talk to what. And it's a very scalable and distributed way of implementing policy. And that what that enables Calico to do is then have a networking fabric that's really scalable. And the way Calico provides scalable networking is by leveraging the principles that we use for internet routing. Specifically, Calico uses BGP for exchanging container IP addresses with each other within the Kubernetes cluster. And so essentially, that's BGP between the Calico nodes. And what that means is the same scalability that you get for the internet, you can get for your Kubernetes environment. I get this question a lot from customers, like, hey, so what's the scalability limits on your Calico networking? And the way I usually respond is, what are the scalability limits on the internet, right? So that's sort of the power of Calico. So today, you look at Kubernetes deployments at scale, going beyond a couple dozen, three, 4 dozen nodes. Generally, Calico is typically the default networking plugin at scale. I had more detail, and of course, this is all available on the common Kubernetes Kubernetes distributions, plugged to the StackPoint folks as well as the DigitalOcean folks. It's available there as well. StackPoint makes it really easy to deploy Calico among on your favorite public cloud, but it's also available in all of the other common public cloud options. In fact, many of them use Calico as a default networking behind the scenes as well. And so what this means in a Kubernetes cluster perspective is, so you have your Kubernetes artifacts, you have Calico running as a pod, and essentially plugged in via CNI, and gives every pod an IP address, shares that IP address with other nodes in a scalable routed fashion, an aggregated route. And so essentially, it's a very simple and scalable model to do networking across very large Kubernetes clusters. Okay? So that's in a quick nutshell what Calico does. Obviously, it enforces policy across multiple orchestrators as well. And to quickly switch to the first demo, so what I have here is basically three instances. I've spun them up on a cloud. Right now, they're not really running anything. And what we're going to do is, because some of you said you haven't installed Kubernetes before, this is going to show you installing Kubernetes is really, 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 really easy. Go home, do it. There's no reason why you shouldn't be doing it. Okay. So what I have is I have a couple of windows on a master node, and I have 3 worker node instances. And so what we'll do is I'm going to use kubeadmin to install, but pick your favorite installer. Kubeadmin is one of the simpler ones. The other installers do more fancy things, which take a little bit more time, but generally they're all pretty simple. The way you get it started is you do a kubeadmin init on the master. It takes about 10, 15 seconds, depending on the image sizes it's pulling down. And if all goes well, if the demo gods are good to us, we should have a master ready to go. And what it's doing is basically setting up the different Kubernetes daemons, the Kubernetes components on the master, and sets them up, and there we go. So the master is sort of ready. We're not completely ready. One thing we're going to do here is I say kubectl. All right, so we're just going to watch what's happening in the master. So we've got kubeadmin that's initialized the master, but we don't have networking yet. And the way you do that is Calico is deployed as a self-hosted. As a self-hosted daemon set. So essentially you're launching Calico through Kubernetes, and it launches the Calico node pod on every node in the cluster as they come up. And you'll essentially see the Calico node pod spin up. Should take a few seconds, and generally that should go pretty seamlessly. The next thing we do is we will simply join each of the worker nodes to the cluster using this command. So we could just go ahead and do this on each of the nodes. And what you'll see is you'll see a Calico node spinning up for each worker node. And it should take a few seconds, and they should all get the IP addresses, and you're up and running. So in effect, what you have now is a 4-node Kubernetes cluster. You have a master and 3 worker nodes. That did it take 2 minutes, 1 minute, right? Honestly, this is super, super easy. So go home, try it out. In fact, you can try it out right now. Okay, so you have your Kubernetes cluster running. So let's now get to the Istio part. But before we get to the Istio part, I want to actually give you a little bit of intro on what that is. Before I do that, just a quick plug for Calico. So this is super simple, as you saw. Shouldn't take you more than a minute or two. We've got clusters of thousands of nodes. It's pretty common for Calico to be deployed. We have a customer with something like 9,000 nodes, right? So this thing scales really well. Essentially, what Calico is doing is leveraging the same protocols that are used in the internet, and so it scales really well. But also seamlessly works with things like Istio and Envoy because it doesn't do anything too fancy. It keeps the infrastructure really simple. It uses pure unencapsulated networking, so it doesn't try and create overlays. And so by avoiding overlays, it keeps your operations really simple, but it also helps it integrate really seamlessly with things like service meshes. And finally, from a security perspective, it leverages Kubernetes network policy to provide isolation. So coming to Istio and Envoy. So what is Istio? Istio and Envoy together, they work hand in hand, are an implementation of a service mesh for Kubernetes. Fundamentally, what they provide is the ability to provide application level traffic management and load balancing, and the ability to provide resilience across failures. So if you have your application that's being served up by multiple services or multiple pods at the back end, and you have individual pods that come up and down, Istio and Envoy work hand in hand to provide the ability to monitor the response times, to look at telemetry, look at various factors, and to sort of load balance your traffic intelligently. If you want to do things like canary-style deployments or AB-style deployments, you can do that with policy, and that's the policy part of Istio and Envoy. They can also do interesting things like seamlessly provide security, both encryption and authentication, so Istio leverages something called SPIFFE, which is a security production identity framework for everyone else. That's what the acronym expands out to. But it's a concept that I think Joe Beda came up with, one of the founders of Kubernetes, formerly at Google, now at Heptio, on how do you provide sort of certificate management to be able to isolate individual flows from each other and give them a distinct identity, and to do that at scale. And so Istio and Envoy help. Istio sort of implements that and leverages Envoy for that. And finally, to be able to provide some detailed telemetry and reporting for what your applications are doing within your Kubernetes cluster, and to be able to report back on sort of visibility and dashboarding and give you some nice telemetry. Maybe also plug in other tooling such as tracing, such as tracing, Prometheus for statistics, to be able to do things like graphing of your microservices flows and give you visualizations of that. So there's a bunch of different capabilities, right? And all of these are exposed through this concept of a service mesh. So what is a service mesh, and how is it implemented? So the concept is essentially, so you have something called as an Istio pod, which is essentially a controller pod. It sets up the control elements of what the service mesh is required to do. And on each pod in your Kubernetes cluster, you get a tiny little sidecar of really, really highly efficient and really small, something like 10 megabytes, 10 to 12 megabytes, depending on what options you package in, that is injected as a sidecar into every pod. And that Envoy sidecar, the little E you see there's the Envoy sidecar. It's built with C++. It was actually built by Lyft, the car ride-sharing company Lyft, and they open sourced it sometime last year. And it's something that's been getting a lot of traction. And so Envoy runs as a sidecar in every pod, and essentially it functions as a proxy within the pod. And the control functions for that sidecar are manipulated using Istio, right? So Istio runs as a pod in your environment, and it manipulates the rules under which Envoy operates. So you have a whole bunch of flexible operations that you can program in via Istio that are then enforced by Envoy as traffic comes into and out of your microservices running on top of Kubernetes. Okay? So you had a question?
How does it compare to Linkerd?
Yeah, let's hold that question till the end. I want to come back and talk to that. I want to just do a quick demo, and we'll do the comparison between Linkerd and Istio and Envoy.
What's the memory footprint of Envoy?
Envoy is about 10 to 12 megabytes. The question was, what's the memory footprint of Envoy? So that's about 10 to 12 megabytes. The other question was, how does it compare to Linkerd? We'll come back and talk to being a sidecar. Linkerd can also run as a sidecar. Linkerd is Java, Envoy is C++. So there are different sort of options there, but we'll come back and do a more detailed comparison.
So just one quick question. So Istio itself is a daemon set? Is deployed as a daemon set?
Istio runs as not as a daemon set, but you basically have an Istio, you have a replica set for Istio. And so you essentially have the Istio controller running as a pod in the infrastructure. It doesn't necessarily have to be running on every node in the cluster.
But it does make sense to run more than one per node.
Correct. Okay, so let's do a quick install of Istio and Envoy. Again, this should be really simple. This is Kubernetes, keep things simple, right? So let's get back onto the master. We have our cluster running. And I'm actually running the earlier release. We just, the team actually just released 1.0.2. I'm actually running 0.1.3, but it shouldn't really matter. So The first thing I'm applying via kubectl is the RBAC rules for Istio. And so essentially it's setting up the different service accounts and the permissions for that. So Kubernetes 1.6, that's essentially now you have RBAC, so you set that up first. The next thing you do is install Istio itself. And you should see the pods come up here. And there you go, so it's up and running. Istio also provides a few add-ons, so you can install them as well. So there's things like Prometheus, Zipkin, Grafana. It provides a few add-ons, and so essentially what you're doing is you've just installed those add-ons. So again, that hasn't taken very long. So you now have Istio and Envoy running. And to give you an idea of what these look like, so if you do a, I didn't set up a load balancer, so I'll just do a, kubectl gets service, and I'll use the node ports to talk to the things directly. So for example, Grafana is 32.290. So if you look at what they look like on a browser, so there's your Grafana dashboard. Let's go to the Istio portion. Make it a little smaller. At this point, there are no transactions. You don't have any services deployed, so it's pretty empty. We can come back and look at the others, but you know, there's Prometheus, there's Zipkin. It provides .viz graphs as well. So there's sort of different additional services that Istio provides, but you know, it just deploys them as add-ons on Kubernetes. So there you go. So there's your Istio running. So now the next step is we actually can come back and try and install an application on top of it, a microservices application to actually give you the power of Istio. Because then you can start to expose the more advanced traffic management, the more advanced security, the more advanced telemetry, and being able to use telemetry to be able to reroute across failures, be able to do things like A/B style deployments. But before we do that, I kind of ran through this really quickly. How many of you guys actually understood how Istio is working? Okay, you've probably been reading ahead, probably. So let me go back and explain it for the rest of you as to what's happening behind the scenes. So we just deployed that. But fundamentally, the way this works is essentially you have this Istio that's running in the environment. And Istio is essentially creating the control rules to have the Envoy sidecar in each pod. The Envoy is actually acting on the rules. Istio is what's setting up the rules. So the users will interact with Istio using something called Istio Pilot, which provides the front-end API for Istio. It used to be called Istio Manager. It's been renamed as of the next release. I think it's going to be called Istio Pilot, which is what I've used here. And in effect, the control flows, the users will plumb the rules as to how they want the traffic managed for their microservices, talking to the Istio Pilot component. Along with the Istio Pilot, there's a couple of other components, all of which they work hand in hand with the Istio proxies. The Istio proxy essentially is an enhanced version of Envoy that's running as a sidecar in every pod, right? One of those is called Mixer. Mixer is a function by which you can leverage things like telemetry, what's happening in the real world, what kinds of response times are you seeing from different instances of the application. Are you seeing, for example, better performance here, or is one of your locations, are you seeing mediocre performance? So you can use that sort of telemetry to dynamically create policy to say, if you see this sort of performance threshold exceeded, start redirecting your traffic. You can also do things like, based on certain policy, redirect traffic a different way. So that's what the Mixer component does. The Istio auth function provides the security, and I have a slide coming up on that as well in terms of what it does. But essentially, that provides the encryption, the identity to be able to manage the encryption and manage flows on behalf of the application, right? And all of that is pushed down into the Envoy sidecars running on every pod. And then once those rules are actually in the Envoy sidecar, the Envoy proxy then, in a transparent fashion to the application, provides the necessary traffic management or security or other service mesh functions so that independent of the application knowing about this, all of these are provided as part of your Kubernetes fabric. Okay? And so that's architecturally how this works. And so Envoy works as a sidecar, and the Istio control components work separately from that. Istio pilot itself is designed to work across multiple orchestrators. Right now, the focus is Kubernetes, right? In the future, there's hopefully this will be expanded to other orchestrators, but right now the intent is to start with Kubernetes to make sure this works really well with Kubernetes. But the architecture itself allows itself to have a plug-in model to support other orchestrators. Coming to the Istio auth portion, which provides the security. So like I said, Envoy is the sidecar proxy that's actually doing the actual packet redirection or the actual functions, the data, it's in the data path. The Istio control components are actually creating the rules talking to the Envoy proxy, sidecar proxy. And as an example, one of the functions that is provided here is the ability to do transparent to the application knowing about that mutual TLS and basically symmetric TLS. And to be able to do that using not just a single certificate authority, but a certificate authority with delegation to multiple CAs that are specific to individual flows and identities. So you can actually do some pretty sophisticated identity and security based on identity that allow you to have independent CAs for individual application flows if you so want it. And to be able to do that transparently of the application. So the application is just talking via what it thinks is HTTP, but the traffic going on the wire is encrypted using a CA chain, essentially. Okay? So there's some pretty advanced capabilities here, and this is just a quick glimpse as to some of those capabilities. And Mixer, like I said, has the ability to leverage things like telemetry data from a variety of backends. Maybe your cloud provider is providing you telemetry. Maybe Prometheus is providing you telemetry. It has the ability to get telemetry and other data from a variety of backends, and to be able to leverage that to dynamically create policy or add to the policy that's being created so that Envoy can sort of redirect traffic based on what you're seeing in the real world, right? And it's a very powerful concept. And in terms of the kinds of traffic management you can do, and these are just simple examples, there's a lot more sophisticated examples if you go to the website and look at some of the concepts there, and there's still a lot more being developed. But being able to do things like redirect traffic based on application headers or HTTP headers to a canary version. So for example, if you want to try out a new version of an application, you roll it out, but say only users who are logged in with a certain username will be redirected that way. All other users will get to the regular production version of the application. It's a way to try out new builds before they're necessarily production ready of your application, by the way. You could do things like use user agents or other HTTP headers. So for example, you could redirect your iPhone traffic versus an Android traffic. I'm not sure why you'd want to do that, but people do strange things. You can do all kinds of interesting sort of redirections and traffic management based on application headers. So you guys still with me? No one's sleeping? Okay, you had a question?
Might be too specific, so maybe something for later. You talked a bit about identity, like application identity. I can see how that works in the kind of microservice type Kubernetes. But something I know I've been wrestling with is like, okay, we have a Cisco at the back end. I'm talking to my database. I need to configure a firewall rule in the Cisco that I guarantee the type of the application identity running.
Yep. Yeah. So the question is, how do you manage identity beyond Kubernetes to other infrastructure that's running on other environments, right? And that's a really good question, but it's also a really advanced question. One part of that I'll touch on in a minute when I talk about how you do policy along with something like Istio and Envoy. But that's a question I might have to come back to, and in fact, we might have to take it offline. So anyway, let's try deploying an application. This is the sort of the Istio canonical example that they have published on the website. Essentially, it's a microservices application with multiple tiers. You've got a front-end tier that's something called a product page, which is a simple bookstore kind of product page or book review site product page. That could potentially redirect to one of multiple backends, providing reviews on that bookstore. And so those reviews get stored in the backend thing called ratings, right? And so this is essentially a multi-tiered microservices application, multiple microservices sort of collaborating with each other to perform a function. And so what we'll do is we'll deploy this on top of Istio, and then we'll do a couple of things. We'll actually try and define policy. So to do a couple of things. One is Istio takes care of transparent redirection and securing the flows, but it doesn't take care of things like the network policy to make sure that the reviews application is only accessible to the product page and that people from the rest of the infrastructure cannot directly talk to or attack the reviews application. To make sure that people cannot talk to the ratings application directly. So basically do that sort of pinhole policy that says only this application instances can talk to each other. And to be able to do that, that's what Kubernetes network policy comes to play, right? So that's where we've been collaborating on some of that network policy integrations. But before we get to that, let's actually deploy the application. All right, so we are here, so everything's running, no restart, so that's a good sign. All right, so don't actually need to do that in the newest version, but that's fine. Just want to make sure I get the Istio command. Okay. So there's your bookend for application, and essentially, mistake there. The way you do that is cube inject. Essentially, what you're doing is you're asking Istio to inject the Envoy proxy into the pod using the YAML for the application. So that's essentially how you do it. And so essentially, Istio has injected that. Kubectl is launching the pods. It should take a few seconds for the application. The application is a little bit heavyweight at this point, so it takes more than like 2 or 3 seconds, but it should come up pretty soon. Let's give it a second here. While we're doing that, the way you actually distinguish between these sort of backends on the application is one of them provides red stars for the reviews, one of them provides black stars, and one of them doesn't provide the stars at all, right? So that way you know which backend you're going to. So when you, depending on if you have rules or not, if you're just doing default round robin, every attempt will get a different sort of colored star. And then you can use flexible rules to redirect to versions of the application. Let's see if this has come up. All right, it's up. Now, actually, before we do that, let's do one more thing. So the Ingress is on port 31224. So if we go into product page, there's your little bookend application that's been deployed. And if you just do a reload, you should see different instances coming up. So this one's with the black stars, this one's with no stars, this one's with the red stars. So essentially you're doing a simple load balancing, right? And so essentially you're redirecting your front-end product page application to different backends right now without any rules. Istio simply does round robin, right? So that's the default. Now let's get to some of the more powerful concepts of Istio, which is being able to do more advanced redirections. So I had a couple I used as an examples here. So for example, I have this little YAML that says redirect to version 3 of the application if the user is Karthik, right? So if someone is logged in as Karthik, then always redirect into version 3. So if you do this, so you would do right. So now if you go back here and do a reload, now it's still going to all the versions because I'm not logged in. So let me log in. All right, so now I'm logged in as Karthik. Now if I do a reload, it always goes back to the third version, which is the red stars, right? So a little bit of how you can do some flexible routing based on things like HTTP headers or user logins, right? So you can try canary style deployments. Another example of something you can try. So I'm showing you Calico Cuddle right now. That's the Calico version. It's telling you what's actually the current policies in the system. It tells you all the different workloads right now. So there are obviously different services running, and there's different sort of policies applied to them. And so I can do things like, but now if I go to,
Maybe you could explain the magic that you did with the Istio CTL.
sure. So
I looked it up.
yeah, the question is what's the magic with Istio CTL? So before I get to the policy. So there's two things, right? When you first launch the application, you're doing a Istio Cuttle Cube inject. So what that does is it injects the Envoy proxy sidecar into the pod spec for the application so that the Envoy is launched as part of the application. The second thing I did was I ran this command Istio Cuttle create with a YAML, which is the more advanced policy that I want Istio to program into the Envoy sidecar to do more advanced policy, redirection, security, various other functions. And so essentially that's encapsulated in that YAML syntax. And so this is where you can do more advanced sort of policy redirections. Okay? To give you an example of what so if I do a kubectl get service for things like Zipkin, for example, Zipkin is 31058. So there's my Zipkin interface. But let's say you guys are being nasty and you're starting to attack my Zipkin for whatever reason. I want to turn that off. So what I can do is, actually I need to figure out what's the IP here. Is 158.106.193. So I'm going to create some policy, or I guess I had that already, that says any traffic coming from this subnet, I can use policy coming tied to other environments, Mesos, OpenStack, bare metal Linux instances, IP addresses, IP ranges. That's the power of Calico, is to be able to tie network policy to all of this. To say anything coming from this IP address range, but that's destined to the Zipkin application, irrespective of where that Zipkin application is running on Kubernetes, I want to deny, right? So I could do things like that. So I would do that via Calico. And And so if I look at the Zipkin, for example, so I had another policy there previously. Oh, sorry. Thank you. One minute. There we go. Oh, delete policy, sorry. I forgot the policy part. All right, so now if I try and go back to the Zipkin dashboard and try it in a new window. So it should no longer be able to connect, essentially. Yeah, you had a question?
From the policy and identity perspective, me and my team use, I don't know if you guys are familiar with Hydra and Ladder. Can we plug that, our own policy engine, whether or not it is used on a YAML?
So Calico provides the policy implementation. Now let's talk offline in terms of what your Calico policy, what the other policy engine is, whether it can interface with Calico, because Calico has a sort of open interface, and it's if you look at the Calico policy implementation, it's a superset of what's available in Kubernetes network policy, because the team behind Project Calico helped develop network policy for Kubernetes. So you'll find the same concepts. Typically in Kubernetes, you cannot do things like egress policy today. You cannot do more operational focused elements. Calico does have a few more concepts, but using the Calico CUTL as opposed to kubectl. Now, if you're doing the same thing using kubectl, you can do the same thing, except you wouldn't be able to do the IP address range, or you wouldn't be able to do egress. There's some other concepts that you can do in Calico CUTL that you couldn't do in kubectl, but it's the same syntax, essentially. That was another question?
Yeah. This might be a kind of theoretical question, but and maybe if anyone else is familiar, but if you're familiar with capability-based security versus access control list-based security, what I'm kind of confused about is why all these systems seem to be based on ACL-based security rather than, something more capability style.
Yeah, no, good question. And this, what I was actually showing you is one example of using IP addresses, but the more powerful concepts which Calico can do, which I didn't show today, was to be able to use more policy based on labeling that is done in Kubernetes by default. So for example, in Kubernetes, you would label individual objects like pods to say this object belongs to project A, and this object is a front-end pod, right? Now, when you say capabilities, there's sort of a lot of power encapsulated behind this that are possible using the Kubernetes network policy abstractions that are sort of dynamically implemented by Calico. If you actually go to the Calico project website and the blog post, there's a couple of demos that we published in how you can actually do some of the more dynamic policy in Calico, enforcing this in lockstep with Istio and Envoy. Now, when you say capability, was that sort of what you're asking for or something different?
Well, I mean, labeling is an example of ACL-based security. Right?
Okay, so what were you referring to then?
I mean, it's an abstract question. I probably it's not appropriate for me to explain what capability-based security is.
Okay, let's talk offline because I think I know what you're talking about, but let's go into that in more detail offline. There's a question in the back. I think this was sort of the presentation, so that was sort of a demo in honor of the British election. You know, kubectl, calicoctl, istioctl. Go play with it. It's super easy to do, as you guys saw. Right? Questions?
Yeah, so for those of us that have been running Calico for a while, how does Istio live side by side in a traditional Calico architecture with Calico policy? Is everything copacetic working together?
Yeah. So there's like 2 or 3 things which I'll highlight for you. There's actually a lot of, the Tigera team, the Project Calico team has been collaborating with both Envoy and the Istio team going back a ways. But I'll give you a couple of examples. One is, first of all, from a Calico perspective, this works seamlessly. Calico being a very simple and scalable architecture, it doesn't get in the way. So unlike if you're using things like maybe more complex overlays where sometimes you might be fighting with each other in terms of how an application level traffic management fabric is trying to route traffic versus a infrastructure. So that's one thing, Calico works seamlessly. The second thing is I gave you the example where in something like Istio, you're doing flexible traffic management and policy based on application level artifacts. Calico does traffic management and policy based on layer 3 and 4. And so when you look at this, these all work seamlessly together and it gives you security at all levels of the stack. So for example, when you look at your laptops today, how many of you guys have firewalls running on your laptops? Hopefully all of you, if not, you're going to be in trouble, right? And that's despite the fact that you're still using things like SSL for your application flows. That's despite the fact that you might have applications that have their own protections. So typically in a real world environment, you want to have security at the network level that's doing certain things, and you want to have security at the application level that's doing different things. So that's the way I would describe what Istio and Envoy provide, which is at the application level, versus what Calico provide, which is at the network level, right? And they work hand in hand. And so if you go to the Project Calico website, we actually had a blog post on examples of how you can do network policy in Calico in conjunction with Istio's policy, so that as this application gets deployed through Istio, the application traffic management is taken care of by Istio, but Calico is simultaneously doing the network policy in Kubernetes so that the application flows that are happening are only the ones that are required for the application. And you're not, for example, allowing people to directly access the backend rating site or the backend. It follows the application flows.
So I guess to ask my question more specifically then, does Istio impose itself on all applications within the same cluster, or can I run some with pure Calico management side by side with ones running with this?
You can run both. So Istio, okay. So as you saw the example there, the way you would inject the Envoy proxy using istioctl kube inject, which I think they're working on making it more automatic over time. But you don't need to inject that into every application. So you can have other applications running with Calico and simple network policy as well. I had one other thought I was going to bring up there, but it'll come to me. I lost my train of thought. Any other questions?
Up front.
Probably last question before you're out of time. I'll probably be around afterward.
I want to hear the Linkerd comparison.
Okay.
You just mentioned they're working on injecting it automatically. Obviously, this is a crutch that's useful. It's practical. Are they trying to use that, do that using admission controllers? What has been thought about a more automated way of injecting that site?
There's actually been some chatter on that. I haven't been plugged into the latest, so I'm going to defer the question. I'm probably not the best person to answer that question. I would invite you to just join the Istio Slack. There's actually a lot of traffic on that now. It was publicly announced like a week ago. And so there's been a lot of really interesting dialogue and discussions. So, but I don't think I'm qualified to answer your question, so I'm not going to try and venture a guess as to how they're going to implement it.
The docs, when I was looking up how the map happened,
I know there's been a lot of debates and dialogue as well. Last question.
Hi. So one of the, just a question I thought, there's very smart routing and traffic routing in Istio. If you had a Kubernetes cluster that was spread across, not federated, but one cluster that's maybe across multiple regions or multiple availability zones, can Istio out of the box preferentially pick pods that are in the same region or same availability zone, as it's going for ingress? Or, you understand?
Yes, I understand your question, and there's all kinds of interesting combinations possible there. This is sort of the power of Calico today as well, in that people have deployed Kubernetes at scale across different locations, and there's lots of interesting recipes that I've worked with customers on and I've seen when doing things, everything from ECMP Anycast to interesting ways to be able to do traffic management at the network level. And being able to tie that into Istio and be able to tie the two together so that you can do things at the application level and maybe push things down into the network fabric and vice versa. There's all kinds of interesting possibilities there. So I'd say we are in the early stages of the different kinds of design artifacts and design recipes that are possible. Certainly what you say, I think, is well within the realm of possibility even today, I think, when Istio working with Calico, for example.
Most of the clouds have, a lot of the cloud integrations put in the annotations like what region or availability zone you were in. So yeah, so is that something maybe you should join the Slack and
yeah, you can, but you can
out?
actually do a lot of that today with Istio. For example, Istio, you can do egress as well, so you can redirect to different backend clouds if you need to. You can use telemetry and different pluggable telemetry providers so that you can do some interesting redirection based on the telemetry again. That's sort of core to the Istio functionality today. So absolutely everything you're asking for today is possible today. You can do things purely with Istio. You can do other things with Istio working with the network fabric. And if you actually start thinking ahead to some of the more interesting large-scale design problems you encounter when you're deploying production Kubernetes at scale, there's all kinds of interesting possibilities, which is why at Tigera we are super excited about this. We think this is going to be fantastic to have Istio and Envoy working together with Calico. And so there's a lot that we're doing, right? So thanks for that question. I'll leave you with one last thought while the next presenter is coming up, is join the community. We're actually thinking of doing a little bit of a sort of a Kubernetes networking workshop, driving into some of these concepts in more detail, maybe in the next month or two. If you're interested, just go to that link and express your interest, and we'll ping you if we do encounter that, or we do host that workshop here in New York at some point. Okay?
Awesome. I have one final question. It's easy from online, which is Istio in the pipeline to be a CNCF project?
Don't know. I don't think it's come up yet. I'm sure there'll be interesting dialogue on that going on. Obviously, the CNCF is, for example, recently CNI got pulled into the CNCF as a CNCF project. I wouldn't be surprised. There's a lot of interesting possibilities here, but I wouldn't venture a guess there. Your guess is as good as mine. Yeah. Okay.
Yes, apparently yes online.
Thank you.
In process. All right. Up next, we have Flynn from DataWire. Oh, yes, round of applause. And Carlos, somewhere around there, is going to grab you and ask you about Linkerd. Up next, we have Flynn from DataWire.
I'm Flynn from DataWire. I'm going to be talking to you about Ambassador and Istio and about the fact that, at least for me, all this stuff usually feels like herding cats.
If we can.
So, I'm also going to be running a couple of polls while we go through this. Easy one to get started. You can deal with this from phones or laptops or whatever. Go ahead. We'll take a couple of minutes. I'm really curious to see what the answer is. This is looking awfully familiar. I'm sorry, say again? If you go up to pollevy.com/Flynn707, then you can answer there. All right, excellent. Surprising, but excellent. So we've actually heard a fair amount of the stuff that we've been hearing earlier this evening has really been from the perspective of operations, which I'm going to do this from the perspective mostly of development, since I spend most of my time somewhere between development and I just want to get my stuff done. And it's honestly kind of an interesting time to be a developer. One of the things that's going on right now is that we're finding that the leverage of an individual developer has been massively increasing recently due to a few different things. One of them is the whole standing on the shoulders of giants idea. There's a bunch of stuff out there in the free and open source software world that actually lets us get a bunch of stuff done without having to constantly re-implement wheels. That's kind of nice. We've been finding that the whole DevOps thing, this idea that you can accomplish a fair amount of stuff if you take the radical step of allowing your developers and your operations people to actually trust each other. That seems to help. It's kind of cool. And we've also, this is a recurring theme at DataWire, we've been finding that the whole microservices thing tends to be working out pretty well. And I'm going to get into that in a little bit more detail here. The whole idea behind the whole microservices architecture is stop building applications that are one big thing with everything linked into it that you have to change all within lockstep all the same time. Instead, split it up into a bunch of small services, each of which knows how to do one thing, hopefully does it well, and then you let them talk to each other. And importantly, you let the teams that are working on those things not have to operate in lockstep all the time. This turns out to be a pretty handy way to go very quickly because you get to parallelize development. There are good things about it. Like I said, you get to go very quickly. Developers often end up much more quickly able to own something that they can call their own. This is a nice thing if you're a developer. Likewise, having the freedom to choose what sorts of tools you want to work in is a nice thing if you're a developer. But really, the big deal is that you can go fast because you can have people doing things without getting blocked on each other all the time. That's the good news. It is not all good news. This is where the cat herding metaphor came to mind while I was putting this together. If you are deliberately splitting up your product into a bunch of little services that all have to talk to each other and allowing people to work independently and release independently, what you find is that the releasing independently part and deploying independently part, those are requirements. They're not optional. If you want to go fast, you must allow the teams that are doing this to operate not in lockstep with each other. That means you have to always be prepared for things that you depend on to change while you're working and a lot of other entertaining little things like that, which effectively mean that you're developing a large distributed system. Distributed systems have a bunch of interesting properties. Basically, as soon as you go from making function calls to making network calls, then your life as a developer gets to be a lot more challenging. And your life as an operations person gets to be a lot more challenging as well. You have to deal with things like not just that your teammate who's working on a service that you rely on released something that doesn't quite work, but you may have to deal with the fact that the network itself broke underneath you. And then you get into fun situations where the network breaks, so a network call fails, so the guy who called that fails, so the guy who calls that fails. You get a cascading failure where one tiny little service kills your entire application, and then you get lots of customers screaming at you over the phone, and nobody has a good day. The ugly part of this is that fixing what I just described is actually really hard. We'll pick on a simple example here of if there is a network failure, you would like to retry, right? But even that fairly simple thing turns out to have a bunch of details. You'd like to retry, but you don't want to retry too quickly. You don't want to retry too often. You don't really want to retry forever. You should stop after a little while and just tell the user that something is broken. You probably want to do exponential backoff or some sort of a backoff so that you can accept that a service that's down for a while might be down for a while longer. All of these things are stuff that ends up being just not feasible for all the developers on a project to independently get right over and over and over again. And that's not a knock on the developers, that's just reality. So, given that we have these problems, are there things that we could do about them? One thing that DataWire has been putting a lot of effort into is simply trying to reduce the operational friction in this part of the DevOps world. A bunch of developers don't really like doing operations. We'd kind of rather be off creating new things rather than remembering exactly what syntax of the kube control command we use. I confess I don't particularly enjoy writing Terraform stuff and things like that. It's, you know, sorry if anybody from HashiCorp's in the audience. It's just not what I do for fun. So there are things we can do to reduce friction. We can do some education, we can do some tooling. One of the ones that often gets missed is we can be willing to be opinionated about the way to do things. Actually, Karthik was mentioning something about this earlier, the whole convention over configuration idea. Another thing we can do, and this is where I'm going to be spending most of my time today, is we can take the hard stuff that I was just talking about trying to cope with failures, and we can start pushing it down the stack. You get it right once, you let everybody take advantage of it. This is what we've done in operating systems for years, for decades. You don't ask everybody to write a disk driver these days or a network driver. You just trust that the guys who did the OS probably did a decent job of it and move on with your life. To me, that's really what the service mesh is all about. You take some solution of this hard stuff, you shove it down into the network layer, and you let the mesh give you a bunch of things that make your life easier, somewhat, to get things right as you're developing microservices. Another poll. Who is using a service mesh already? I don't know, I'm feeling like I'm not doing my job very well so far. I got too many questions, too many answers in column E. But that's okay, we'll get into that a little bit more. All right, so we have some folks already using Envoy. Cool. We have some folks who are using custom stuff, which, whoever you are, I'd be interested in hearing more from you a little bit after this. We've got some folks who are looking into the whole thing. I'm also curious. And hopefully these guys will be able to answer some of that in the next few slides. So, you can look at a service mesh both as a tool to help you get things done, and you can also look at it as a way of taking a bunch of services and collecting them up into a single application. It's kind of an extension of the whole container concept. In a lot of ways, a container is a way of taking a bunch of processes and collecting them into a service. But more than that, a container is also a way of putting an interface around running your service. It's a way that you can let the ops guys just say, well, you can let the dev guys just write to a particular way of getting things started, and then you hand that off to the ops guys, and both sides are happier because there's not as much special code in there. The container gives you a standard interface. It gives you a way of treating a bunch of random processes, whatever happens to be there, as one service. Kubernetes and its ilk are likewise a way of collecting a bunch of those services into a standard infrastructure that lets them all work together. Service meshes, to a certain extent, are about standardizing the operations experience and the development experience together so that you've got a bunch of services that can work together as a single application. Envoy's pretty good at this. Throw Istio into the mix, it can be better at this. You've heard a little bit about Envoy so far, so I'm going to run through this kind of quickly. It was built at Lyft. It's really gotten the tar beaten out of it at Lyft. It's running all the time, it gets hammered on it. They had it running there in production for a couple of years before they open sourced it. It's good stuff. It's actually native HTTP2. gRPC is no big deal for it. Somebody was asking about multiple availability zones. We might have lost him. Was that you? Yeah, so Envoy does that natively. Istio, I don't think actually does a whole lot of that, but it exposes the control so you can get the envoys that Istio is using to do it. Istio, like you heard, the Istio guys like to call Istio a network for services instead of for bytes. It's built by IBM, by Google. As of right before I started this talk, it had 2003 GitHub likes, which was kind of entertaining. And there are actually a bunch of people between IBM and Google and actually us at DataWire working on this now. You heard a bit about the sidecar thing. Some of the other ways you can do this are you take your application and you link it with a special library, and the special library gives you access to a bunch of stuff. That can be challenging if the library is written for a language and a runtime that you don't want to use. So instead, Istio took the idea of just run envoys everywhere. And Istio actually goes a little bit further than that. Istio reaches down into the networking stack in the individual pods and forces the kernel to route all their traffic through the envoys, which is where a lot of its power comes from. As Karthik mentioned, Istio is really a layer of software that sits above the envoys and controls all of them. It gives you a way of defining policies. It gives you a way of doing control. Envoy is the thing that's doing all of the heavy lifting underneath there. So, first off, let me back up. Questions about service meshes. There were a ton of responses of what's a service mesh. Have we finally answered that question, or are there more people still wondering? Okay, if I back up to the other poll, is everybody going to say we're evaluating now? All right, I'll take that as a yes and move on. So the service mesh is a pretty low-level thing. It's all about taking a bunch of services, wrapping them up into a single application, and presenting that in a uniform way to development and to operations. At a layer above that is the API gateway, which is also about collecting services into an application, but it's much more about giving the users of the application, as well as the developers, a consistent experience. It's a place, most importantly, where you can take a bunch of logic that has to be applied the same way across the whole application, and you can put it in one place. Authentication is a big one. Routing is a big one. TLS, things like that, that again, can be challenging to get right, and you really want to get them right in one place and just have all of your services do the right thing. It's a good candidate for the API gateway. You knew this was coming, right? Oh my God, I left it off. Come talk to me afterwards. I'll apologize. Oh, no, wait, you're a special case, dude. All right. So again, mostly evaluating. It's nice to hear that everybody knows what one is. I appreciate that. Thank you. I am curious, if you don't mind shouting out, is it the guys in this column, are you mostly using ALB or ELB or what? Anybody? Cloud endpoint. Yeah? Okay. Cloud endpoint? Okay. Anybody else? ELB? Just random curiosity on my part. Okay, cool. We wrote our own too, kind of. Ambassador is a self-service API gateway built to use microservices on Kubernetes using Envoy. It works quite nicely over Istio. You don't have to use it over Istio. You can run it standalone if you want to. It provides routing, actually self-service routing, TLS termination, authentication, and it's very important that everybody realize that it's still very early days for Ambassador. Ambassador's been out for less than a month, so there's more to come. I said a moment ago, self-service routing, TLS, and authentication. So we're going to take those. That's actually kind of important. I'm going to go run down that in a little bit more detail. Routing, in this case, Ambassador understands HTTP URLs. It's built on this idea that you can map a resource to a service, where a resource is really a prefix to a URL, and a service is a Kubernetes service. And it routes all HTTP methods so that the developers can use whatever is appropriate without having to worry too much about it. I also said self-service routing. Self-service, the developer is the one who sets up the mappings. There is no gate on an operations person saying this is okay. There's just a REST API that the developers can go and change things with. This is a deliberate decision in service of the idea of move fast and make things. Once again, it's kind of predicated on the idea that your developers and your operations actually trust each other. On the other hand, since there's no gate for rolling forward, there's also no gate for rolling back if something goes wrong. On the TLS side, right now, it's mostly about terminating TLS. A TLS connection comes into Ambassador. It can accept it, do certificate validation, all that kind of stuff. You have to tell it your certificates for your endpoints, and then it can deal with this correctly. Right now, it will do clear text to the back-end services. Obviously, this is not appropriate for people in some industries, like HIPAA is a thing in some places. So again, this is another place where keep an eye open. There's more coming. I'm also not going to talk about it tonight, but Ambassador can also do TLS client certificate authentication. Similar idea, you tell it about your CA certificate and then it can validate it and stuff like that. We also have custom authentication built into Ambassador, where as a connection comes in, Ambassador can actually make a call out to another service to handle whatever type of authentication you need. We decided to go with the external service for flexibility. It's basically the sort of thing where a connection to the auth service gets made, we pass on the request headers from the incoming HTTP connection, and then the auth service hands back an HTTP status code along with, its own set of response headers, obviously. If the auth service sends back something that's not a 2YZ series, then all the response information from the authentication service gets handed back, which means that the auth service actually has an enormous amount of control over things like cache invalidations and all sorts of things like that, while also keeping it fairly simple for a developer. One of the interesting things about this one is that if you're using that, it applies to every microservice, which means that if you are writing a microservice and you receive the connection at all, then the authentication piece has already happened and you know it's good. You could write the auth service so that it doesn't require this for everything, and in fact, we'll see that in this demo later. We also have the one that we supply as an example for that external auth service does a very primitive basic auth, but that's okay. There's a lot of other stuff it can do. I mentioned Ambassador and Istio. They're both things built on Envoy. We've been talking a lot with the Istio guys. They work pretty nicely together. We let Istio do all the heavy lifting of the service mesh. We let Ambassador worry about controlling Istio's Ingress. There's a fair amount of stuff coming down the pike on that one as well between DataWire and the Istio guys. All right. Any other questions so far? Okay. Some of the stuff on the roadmap for Ambassador. Obviously, there's a bunch of stuff we could do much better with Istio right now than we do right now. Presently, we intend to keep supporting standalone operations with Ambassador. One of the things that we want to do is to make custom filters a first-class thing for Ambassador, so that rather than having to write filters in C++, you can go and write them in some embedded interpreted thing. Just maybe you end up rewriting in C++ later, maybe you stick with it if your application is one where that works for you. But again, one of the things that we really like is reducing friction, having some way that you can just go and slip something in to work with, all about reducing friction. And of course, Istio has a bunch of really, really cool stuff embedded down there in the service mesh for how it can do rate limiting and traffic control and all of this stuff, which Ambassador should be able to control, but it's still really young, so it doesn't yet. If you're interested in more, http://getambassador.io. Strongly recommended. All right. A couple more things before the demo. We are curious about what sorts of things you currently do or think you might use an API gateway for. You can rank them in order of importance. Unless I got it wrong. You know, seeing this on the slide makes me realize that I should have mentioned this when I was talking about service meshes and did not. One of the other things that a service mesh can do, if you set it up correctly, I mentioned that distributed systems are typically really, really difficult in terms of visibility. If something goes wrong, it can be very hard to see inside to figure out what went wrong. And a properly configured service mesh, as Karthik actually was showing earlier, you can use things like Zipkin, and you can use things like statistics. Envoy has built-in statsd feeds, for example. All of those can give you much better visibility and get you closer to where you were when you were working with applications that were all just a bunch of processes in the same box, and you could go and easily run traceroute on them or things like that. So I've seen authentication and traffic management flip a few times, but looks like we're pretty stable in the rest of them. Which of those, and this one should allow you to pick multiple options, which of these got you started using an API gateway? Again, just out of curiosity. Big surprise, same order. Finally, for those of you working with custom stuff, what languages appeal to you on this? Somehow I'm not surprised that the language poll is the one that's getting the most active stuff coming back to it. Okay, once again, if you were one of the other responses there, I'd be very interested in hearing what you're thinking of. Okay, that's it for the presentation on Ambassador. Questions? All right. As they say, never begin a demo with a comment more predictive than watch this. All right, I have a Kubernetes cluster that's already running Ambassador and Istio and Prometheus and Grafana and things like that. My thanks to Karthik for going through the pain of letting everybody see getting that deployed so I don't have to. I also am going to start the book info demo. Pretty much the same demo, a couple of things that have been lightly tweaked, but it's the same thing where you go in, you see that you can go to a product page, it will show you some other stuff. While that's going, Ambassador currently is controlled with the a REST API that runs on a port that is not exposed outside of the cluster. So we'll set up a port forward to get at that. Anybody want to bet that this is the try that takes longer than 2 minutes and that script stops running? Anybody? The odds are going down. Yep, okay. Pulling containers. Pulling images, rather. The funny thing is that this is actually running in Amazon, so bear that in mind. Okay, one of them's running. 3 more to go. Well, while it's doing that, let me go ahead and point out a couple of other things really quickly. The ambassador is actually already running in this thing, so we can ask it what its current set of mappings is. It's empty. There are no mappings at present. We can go ahead and create a couple while waiting on the pods to get started. If you look over that one, this is basically saying anything that starts with /reviews, hand it off to the service called reviews v1. We're going to call that mapping reviews map. And if we did the same thing up here for the product page itself, anything that doesn't match the reviews thing goes off to the product page. And if we ask for mappings now, we can see that those two exist. So far, so good. Hey, everything is running. Excellent. So, there is an Ingress controller running here. It has this really horrible name. I have cheated and given that the name ambassador.k736.net. because that makes it much easier just to do things like this. Gives us a web page. If I open that in a browser instead of using curl with it, then you should see something here that looks remarkably familiar from last time. We'll just go ahead and request a normal user here. You'll notice that we are, in fact, getting the reviews that have no stars. That's the reviews version 1 thing. We can also, and this I did not set up a pretty name for, so we'll just have to use the horrible name from Amazon for it. Well, we can also go through and see the Grafana thing. You can see that, yes, those services are running. I'm actually not going to do much with this since Karthik already did. But I will point out also that one of the other entertaining things that comes along with the add-ons from Istio is that you can ask it for a nicely rendered graph of your service hierarchy, which is kind of cool, actually. Okay. But back to book info. If we come over here, we can bring up version 2 of our review service. That's the one that has the black stars. If I go back over here and I reload this page, I still get no stars because Ambassador is routing everything to version 1. If I come over here, let's see if I still have this. Nope. If I come over here and I swap this over to version 2, whoops. Bear with me while I remember how to type. There we go. So now what I just did was change that mapping with one command over to reviews version 2. If I come over to the web browser again and reload, look, I have stars. And that, I believe, is about it, because I think we're running short on time. But if there are any other questions, now's a good time.
I'll take question 1. Oh, all right. Apologies for the lights. They're actually automatic, so that was
no problem.
It was the building. Thank you so much.
Thanks for having me.
Coming out. We'll reach out about next month. Next Wednesday, I'll send you an email if you're on the Kubernetes list. We're going to be out in Seattle. Heptio, everybody knows Heptio? Yes, they're coming out of stealth mode, and we're going to be broadcasting from their offices next Wednesday. I'll send you it's actually YouTube, StackPointCloud Live is the URL. So next Wednesday, but I'll send that out to you guys. If you have any questions, you can reach Flynn and DataWire. The team is here, and you can reach them on Twitter at _Flynn.
That's me.
Thank you so much.
Thank you.